So a trimmed mean, this is on page 122. A trimmed mean is the mean calculated by disregarding an equal number of data points from both ends of the range. Again, you might be looking at that and be like, what the heck does that mean? Well, basically, if I were to give you a bunch of numbers, let's say one, I'll type it. If I were to give you numbers of, how did people score on, like, let's imagine we have, we had an assignment of there was 5 people. Someone got a 1%, someone got 70%, someone got 75%, someone got 8%, and someone got 110% for extra credit. And I want to see what the average was. Well, I'd be like, I might not count this one. Maybe this person just didn't hand it in. And, oh, this person cheated. So I'm looking at taking away one from both ends, an equal number of data points from both ends of the range. I'm like, I don't want this one in here, but in order to keep it fair, I need to get rid of something on the high end too. That's what a trimmed mean is. I'm literally trimming some of it off. So, so if there's a number that's quite different from the other numbers in the list, again, if Michael Jordan, famous basketball player, was in this room and we were measuring our heights, he's an outlier. He's like 7 feet tall or something like that, right? Like, we're not going to include him in that. That skews the data way too much. So if there's a number that's quite different from the others in the list, this number is what's called an outlier. Again, if we're like, hey, how much money did you guys make this week? And Elon Musk was in the room, he's an outlier. We don't average making millions of dollars a week. He makes too much money to influence that. So this is what's called an outlier, when there's a number that's just way too different from the entire list. So an outlier can have a big effect on the arithmetic mean of the data, on the average. Again, if I'm like, hey, what's our average salary? And again, Elon Musk is here, that messes with it. We don't want that. So to account for this, we use a trimmed mean to be a more representative measure of that central tendency. So when there are outliers, a trimmed mean can be found by omitting an equal number of values from the upper and lower ends of the data set, aka take something away from your lowest end, take something away from your highest end. That's what that means. I'm just gonna... Okay. So let's go through a little bit of an example of this. First one here. So we have a data set contains these numbers, 3, 9, 5, so on and so forth. We're always going to quickly calculate the arithmetic mean. Now, the first thing I'm going to do is I'm actually going to reorder this. I'm going to rewrite this in the correct order, which is 3, 4. I'll move it up in a second, just so I can see. So 3, 4, 5, 6, 8, 9, and 20. So I've just put this from smallest to biggest, right? So if I want to calculate the arithmetic mean, this is the fancy way of saying the average, right? And as a quick reminder, how do I do that? I need to, this is question A, add these numbers up, 3, 4, 5, add all those numbers up. So that's going to be 7, 12, 18, 26, 35, 55. And I'm going to divide it by how many numbers are there? There's 7. So it's literally going to be 55 divided by 7. Which, if I spit that into a calculator, the mean itself is 7.86. Right? Average is pretty simple. Boom, that's what it is. But what we want to do is we want to actually identify an outlier here. Now, which of these numbers, if you're looking at this list up here, is probably the outlier? 20, right? It's way different than the other ones. So we obviously need to get rid of that. But remember, this is a trimmed mean. To trim it, I need to trim from both ends. So if I'm getting rid of my 20, I then need to get rid of something from the other end, which is the 3. And so I'm going to calculate the trimmed mean now with question B. So now, what do I have? If I add these up, it's 4 plus 5 plus 6 plus 8 plus 9. Because I've taken something away from both ends. So that's 9, 15, 23, 32. 32 divided by, there's 5 points now. I'm not dividing it by 7 anymore because I've taken 2 of those data sets out. Which will
just take the highest and the lowest.
Yeah.
Okay.
Yeah. Which is going to give me 6.4 as my new trimmed mean. So what's the difference between these? What's the difference between an arithmetic mean and a trimmed mean?
Arithmetic would include the outliers, and then the trimmed one would not include the outliers.
Yeah, exactly. Yeah. The arithmetic again, you'll never use this word in like a sentence in real life. This is the average, right? The arithmetic mean, the average, calculates with the outliers. It's using those outliers. That's when we're like, yeah, we have Elon Musk here. We're gonna add his salary to it. Obviously, that's not a good representation. So if he was here doing that, we would probably say the trimmed mean removes the outliers. Right? So trim mean seems simple enough. It's the same thing. We just have to cut some stuff off the edges. The big thing here, though, is identifying what's the outlier and what's not. And you can cut more than one out. So if we keep going here, wow, I gave myself a lot of space there. So I'm going to give you just a couple. I'll give you like 2 minutes. Try out question 1 using that same stuff. 2 minutes. Try out question 1. You're going to calculate the arithmetic mean. That's your normal average, and then you're going to use that trimmed mean in question B. So 2 minutes. Try it out. It's okay to get it wrong. We're practicing the skill. So again, I always recommend put stuff in order here. Normally for the mean, we don't have to, but what second we add a trim mean, we do. So if you add these numbers up, what'd you guys end up getting for that?
2185.
Okay, so there's 2185, and there's 10 data points, so you divide it by 10, which will give you 218, 218.5, perfect. Right, so that's the arithmetic mean, right? Now with the trimmed one, what's our outlier?
524, 476, and 125.
There's 2 of them, you're right. 476 and 525. So I need to remove both of these from this high end.
Oh, you wouldn't have to do 125.
Oh, and well, because I have the 2 on the far end, I need to remove 2 on the other end then.
Oh, okay.
Yeah. Yeah, so you always have to trim it from both sides here. So if you do that and you add this up, so now I have 6 points. I've removed 4 of them, right? 132 plus 133 plus 154 plus 164, 165 and 183. 931 is my new total but I still need to divide it by how many points do I have now?
6.
6, yeah, because I removed 4. So if I do that, now I'm gonna get divided by 6, 155.17. So we can see how removing those outliers really affects what the mean is going to be. And again, the same thing kind of like usually a lot of people see negatives like, oh my God, what do I do? You still do it the same way. Like, so if we're talking about the highest temperature, you know, obviously it's going to be, oh, sorry, what was the high mean temperature? And you can have a high for a negative, right? Like if it's minus 40 out, but it gets up to negative 20, that's still your high. So you still do it the same way, right? You're going to add all these numbers together. And in your calculator, it's going to look like this. You don't have to write this down, but it's negative 12. Sorry, not in your calculator. This is what's actually happening. It's negative 12 plus negative 14 plus negative 5. But in your calculator, you just put negative 12 minus 14 minus 5 plus 15 minus 8 minus 10 minus 12. You plug all that in there. 26, 31, 16, 24, 34, 40, negative 46. Sounds right. Divided by the 7 days of the week. Should give me a whopping total of negative, oh, I don't even know what. Divided by negative 47 negative 46. Divided by 7, give me 6.57, 6.56. Negative 6.57, sure. Degrees Celsius, right? So even with negatives, you still do it the same way, but same thing. When we have a trimmed one, obviously we have to move the outliers, and we can see pretty clearly, like this is our entire winter right now. Like it's I don't know, I don't remember a February where it wasn't minus 40. Obviously, the Wednesday here is when we had a big Chinook, that warm air come in and warm everything up. So normally, you know, we probably want to remove that. So this is the warmest. What would be the coldest temperature here? Monday, yeah. So you got to remove both of those from here to get your new trimmed mean. So now I'm adding up those 5 numbers. So that's negative 17, negative 25, negative 35, negative 47 divided by 5 new data points. When it's a small set like this, you don't actually have to rearrange it. When it's a big one, like the question above, I really recommend you do. So this is going to give you negative 9.4. Degrees Celsius. Again, removing those outliers really affects it. So like, which one of these temperatures would you use? It's not just about being able to calculate it. It's also about thinking through it logically. Which one of these is a better representation of the actual temperature it would be in January?
Probably the trimmed one.
Yeah, it's going to be the trimmed one. And, you know, so yeah, the trimmed mean is a better, you know, indicator, representative, temperature to use, whatever words you want to use. But it is the trimmed one. Specifically, why? Well, because you can't expect Chinooks. It's more of a rarer activity. You know, most people associate January in Canada as cold. So you probably want to use the normal cold temperatures. So because Chinooks are uncommon. Like this winter for now, like the winter we're in right now, no way this is going to get calculated for stuff. This is the warmest winter like ever. Okay, so that's what trim mean is. We'll let you give you a chance to do that one later. I'm gonna give us we're gonna look at the other thing here, which is now weighted means. So in a weighted mean, not all the data points are of equal value. What's the most common example of this? In school, when we calculate your final grade or we calculate your grade going into the final. Not every assignment is worth the same. Your final is obviously worth a lot more, 40% of your grade. So if you get 100% on your final, that affects a lot more of your grade than if you got 100% on an assignment. Same, the opposite's true. If you completely bomb the final, that has a big effect on your final grade, right? So for example, a teacher might assign different weights to different parts of a student's assignment. Assignments might be worth 45% of the grade. A quiz might be worth 15, and an exam worth the remaining 40%. In this case, each data point is worth a percentage of the total. So again, weighted mean is the mean calculated when certain data entries are worth more than other. Your final exam is worth more than an assignment, right? So let's look at an example of this. So if we have someone who's earned these 4 grades, 85, 72, 65, and 90 on 4 tests in 1 term in their math class. So if each test is worth the same percentage of the final grade, what would be the final grade? Well, what are all of these worth then? How much total percentage can you get? You get perfect everything. What's your mark going to be?
Perfect everything.
Perfect everything. You're going to get 100. I have 100 marks to divvy up, and I'm saying that of this 100, those 4 tests determine that. So logically speaking, wouldn't that make each of these worth 25% then? Because if I have 100%, I have 100%, and if I have 4 tests, well, then that means each test is worth 25%, right? You just take 100, you divide it by 4. But it's not asking me what each test is worth. It's asking me what would her final grade be. So let's think about this. I'm just going to zoom in a second. Here we go. So we have 4 different tests here, and I'm saying that, hey, each one of these is worth 25%. So I got 85% of 25 possible marks, right? So basically, what this is actually going to be is it's 25%. Don't write this down yet. 25% of, sorry, 85%. Don't write this down, of 25 marks, right? That's my first test. Then my second test, I can see I got 72% of 25 marks. In my third test, I can see I got 65% of 25 marks. In my last test, I can see I got 90% of 25 marks, right? And if I do the calculation, I add that up, that's what I'm going to get my answer here. Let's convert the English into the math part here. The second you see the word of, what does that mean?
What was that?
The second you see the word of in math, what does that actually mean?
Out of 25?
It means times.
Okay.
Yeah. So 85% times the 25 marks. Now, I can't times by a percentage. I have to convert that into a decimal, right? You're right. So this is going to be 0.85 because that's 85% instead of it's times 25 marks. Plus 72% as a decimal is 0.72. Again, you notice that I'm putting the brackets here, right? 72% of 25 marks. 65% would be 0.65. 90% would be 0.9. Technically, 0.90 works too, whatever you prefer. So now what I have is I have a calculation I can use. And now you could punch this all into your calculator. One-on-one, that would be fine. Or you could split it out. So I could either punch this in my calculator exactly how I see it, or you can just do a part of it at a time. I could just do 0.85 times 25. The first exam, I got 21.25 of a total of 25 marks. That's what that's saying, right? So in this case, I'm gonna calculate it one by one by one by one. But you could just punch it all in at one time if you wanted. So this is equal to 21.25% plus. So 0.72 times 25, 18. So I got another 18 marks here. Sorry, not yeah, actually 18%, yeah. Then 6.5 times 25 marks. I got 16.25 marks. And then this would be 22.75. Let me double check that. No, 0.5. Right, so does that make sense? Is I have a total of 25 marks here that I can give. If I scored an 85%, that means I get 85% of those marks. If you have a final exam that's worth half your grade and you score, 50% on it, you're going to get 25 total marks to use towards your final grade. So if I add all this up, 21.25 plus 18 plus 16.25 plus 22.5. I can see my final mark now is a 78% out of 100, right? So what about question B? So let's think about this. Question B. So what if her term mark in the first test was worth 10% of her final grade? The second and third were worth 20%, and the fourth test is worth 50. How would I do that then?
You just take the same things just take the same things like 85%, and then you just do 50 or 10 85% of 10, and then 72% of 20, 65% of 20, and 90% of 50.
Exactly. Yeah, so for question B here, how would I do that? Well, I've said the first test is worth 10%, right? There's only 10 marks you can give this person. The second test is worth, second and third were each worth 20. Oops. So all I'm doing is I'm changing, hey, instead of each test being worth 25% of your total grade, now the first one's worth 10, the second one's worth 20, the third one's worth 20, and the last one, which is probably a final exam, is worth 50. Half of her total grade is that one test. So I set it up the exact same way. This first step, you don't have to write this, by the way, to show your workings. You can just go straight to, this is the English part, right? You can go straight to the math part, which is converting the percentages into decimals and converting the ofs into times. I'm just doing that because it's an example. So I'll let you guys finish that calculation there. I'll give you a minute. Give you another minute here. So if you do that, what we should end up here with, we'll give you, this is 8.5 marks. Ooh, 8.5. This is going to give you a, what is that, 14.4?
Yeah.
And again, you could just throw this all in one calculation. I recommend splitting it up because sometimes you just press the wrong button, right? Like you can know exactly what you're doing here. You might just press the wrong button. Break it up, do it part by part by part by part, and it's gonna fix that problem. Next one's 13 marks. Next one here is gonna give you, is that 45? That sounds right. Yeah, it sounds right. And so what does that give you as a final total answer?
I screwed up on my, I asked like 80 bucks.
See, and that's why we break it up part by part, is you've set it up right and our button slip or our finger slipped on the button. plus 13 plus 45. 80.9% is what this person got. That's a final grade. Oops, 80. .9% is a final grade. Okay. Sorry, everyone have that written down? Okay, perfect. Okay, I'm gonna give you guys 5 minutes here. Try out question 4. I'll give you a little bit longer. Question 5, question 6. Ask for help if you need it. Again, this is meant to kind of test our limits here. I'll give you guys about 5 to 10 minutes. Try out these 3 questions here. And again, ask for help if you need it. On here, which is this one. This is on page 127. So we're just going to look at one more here, which is what about if we have repeating items? And we're going to solve this 2 different ways. So what if we have repeating items? You might be like, what does that mean? Let's find out. So when we can use this this weighted mean calculation when there's repetition of entries, when there's the same thing a couple times. The end result's the same as the arithmetic mean. So you can solve it with the arithmetic mean, or you can solve it with the weighted mean. But the calculation's a bit quicker and it's a bit easier usually. So we have someone who's in a restaurant here and they earned 2 tips of $6, 3 tips of $8, 3 tips of 10, and 6 tips of 12. You can solve it 2 different ways. So I'm going to solve it using the arithmetic mean first, which basically means I need to add up all the tips. So I know that there's 2 things of $6. There's 3 things of $8. There's 3 instances of 10. And there's 6 instances of 12. 4. So if I do that, I add all these numbers up, I should get $138. I think that's right. So I should get $138 here, right? That's how much this person made in total with their tips. How many tips did they get in total though? Well, they got 2 plus 3 plus 3 plus 6. So that's 5, 8. They got a total of 14 tips. So if they got $138 in tips in totals, they had 14 tips. I just take 138 divided by 14, right? And I can see that this person makes a total of $9.86 because it's money. I go to 2 decimal places. $9.86. I think that's what I said. So $986 is the mean tip. So this is one way of doing it. Now, if this was a lot even more numbers, maybe we're talking about like there's 100 tips. That gets a little unreasonable, right? So Instead, why don't I use it as a weighted mean? So I could also do a weighted mean. Let's give you a second, just if you're still writing. Which basically means what I'm going to do here is I'm going to group the tips by value. What does this mean? Well, how many times did she get tipped $6? Two. 2 times 6. 2 times $6, sorry. I add that onto the 3 instances of $8. I can see she got tipped $10 3 times. 3 times 10. And I can see that this person got tipped was $12 6 times. So 6 times $12. So I could just do that instead. Which again, I could break it up, or I could throw it all in my calculator in one go. I'm a fan of breaking it up because this way, if you make a small mistake, we can see the error and you're still going to basically get full marks for that. You know, that's just, oops, my finger slipped. But I should end up here now with the same thing, $138. I do the same thing where I divide it by the 14 total entries and I'll get the same amount, $9.86 per tip. Now, in this case, it might not have saved much time, but if you have an entry with dozens, hundreds, it will save so much time. And not only that, you're less likely to make an error, right? You're more likely to be like, oh, is this the 17th 12 or the 18th 12 versus it's 18 times 12. Okay. So what's going to happen now? Let me just circle that, circle our final answers. Good. See if everything's done. Okay, so what's going to happen here is we're going to go up until you got time now to practice this skill up until page 131. Additionally, same thing, you could work on the textbook all the way up till page, where was it? Up until page 135. So I'll just write that in here. So the first thing you can work is you can do the workbook. This is the workbook, exactly what I'm writing on right now, till page, I think I said 131. You could do the textbook. I think I said till page 135. 134 technically. Yeah, sure. I'll give you the assignment here after the break as well. This will be due February 16th. That's the day before. Reminder, no school whatsoever during the 19th to the 23rd. Do not show up. At 2:15, we're going to go over the concept check. This one was quite a short concept check. I didn't even make a video for it. I'm just going to power through it really quickly on there. But this is our plan for today. So it's really just making sure we got this skill down. And then we'll end up going over the concept check. I'll hand out this assignment after the break as well.